of Tectonic Shift, flagship event organized by OJAS 14. Before starting, I would request all the participants to please rename yourselves according to the naming convention. Thank you. Crowned as the country's 7th biggest B School Fest, OJAS is the flagship management festival of SP Jain Institute of Management and Research, Mumbai, with participation from 100 plus B schools and undergraduate colleges from across the country. The fest, in its previous versions, saw massive participation of over 9,000 students registering for 25 events from all domains across the 3 days, even when it was virtual. This year is about making it bigger and better, from the despair of a disconnected illusionary world to coming together in a post-pandemic reality. A promise of change and hope marks the 14th edition of OJAS. Tectonic Shift is a flagship OJAS event. The event consisted of an exciting and challenging preliminary quiz-based round where the participants had to answer questions around the fundamentals of analytics and data science. The penultimate round was an analytics-based case study round where teams had to analyze various data sets and come up with winning business strategies. Now today, in the final round, teams will present a detailed presentation about every aspect of their business strategy and present it before our respected panel of judges. This year too, Tectonic Shift saw a participation from 600 plus students and upheld its legacy of a premier event. After an event spanning 3 rounds, we are finally left with our 8 national finalists consisting of some brilliant analysts from across the country. I'm sure all the finalists are now ready to present their business idea to our judges. I wish all the best to all of you on behalf of OJAS 14.
Talking about the final round, in today's age of digital economy, data is equivalent to what oil was in 18th century, an immensely untapped valuable asset. Like oil, those who are able to see data's fundamental value and learn to extract and use it will reap its benefits in the coming future. Let's embark on a journey of data rush with OJAS 14's Tectonic Shift. By being part of this event, participating teams had a shot at getting to work on a challenging data-intensive case study where they did not just analyze heaps of data, but also use its insights to gain and shape their overall business strategy. Can you feel the rumbling of the data? Can you feel the tectonic shift? I would now like to introduce our esteemed judges, starting with Shailaja Gupta. Ma'am Shailaja Gupta is a product and analytics professional with more than 6.5 years of experience in building products and analytics solutions from concept to launch. She has key expertise in customer experience, interactive Tableau dashboards, analytics, and machine learning. She has also headed the pan-India operations of an NBFC giant, leading the analytics and automation divisions. Not just that, she has many more feathers in her cap, like India's most inspiring women managers list by Inside IM, founder of the IM community, and a YouTuber engaging in educational analytics videos on careers and more with Shailaja channel. Shreya.
I would now like to introduce Mr. Ashwin Jeremy, our second judge for today. Ashwin is a senior product manager at PhonePe and has over 6 years of expertise in product and development on both web and mobile in a range of industries such as fintech, user-generated content systems, B2B product solutions, etc. He was a senior product manager at Ola Cabs before joining PhonePe, where he worked on products in the trust, smart mobility, support, and driver experience teams. He possesses a degree in computer science from Vellore Institute of Technology, as well as an MBA from our very own SP Jain Institute of Management and Research in Information Management, and he is an alumnus of 2017 batch. I extend a warm welcome to all our judges on the behalf of Team OJAS 14. I'll now be debriefing regarding the timings for individual team presentations. Each team presentation would need to be completed in exactly 10 minutes. We'll show you an indication at 8 minutes and a hard stop after 10 minutes. Q&A time for each presentation would be 8 minutes. Pratyusha.
So without further ado, let me call upon our first team, Team Data for Dinner from IIM Calcutta, to present their business solution to our judges. All the best, team. The presenting team has to keep their hands raised, and we'll let you in the breakout rooms when you are asked to do so. I request the judges to enter the breakout rooms and make themselves comfortable.
Sorry for the communication gap. We'll be doing the presentations in the main room as well. Anik, could you please pin the participants and the judges? Sorry for the miscommunication. Team Data for Dinner, you'll be sharing your screen shortly while the judges are back from the breakout room. Please keep your presentations ready. We can start now.
Hello everyone, good afternoon to all. I'm Harika. I have my teammates Varshit and Aryan here. We are from the team Data for Dinner. Let us see the observations, inferences from the data sets given and analysis applied on the data set to get some insights and recommendations in the case of OJAS banking services. Our problem statement is to create a business strategy to optimize the future lending decisions and identify the most influential parameters affecting the loan defaults. We have the information on historical lending decisions of the firm, the behavior, lifestyle, and credit history data of the potential customers. During the analytical process, it is observed that the data is imbalanced, with just 8% of the total applicants defaulting. Decision making and recommendations are based on the most important features found after analyzing the data. Going to the next slide. This is the process we followed in the analytical space. First, both the data files are merged and the data is treated for null values and outliers. Missing values are assumed to be missing at random in the given data sets, and median imputation was used to handle the missing values. Correlation analysis and plots of various columns versus target columns are observed. New features are also added to the data set as a part of feature engineering. Feature selection is made using statistical methods, after which we did modeling and finally made a business framework, which is discussed in detail in later slides. Going to the next slide. Let us now see some results of our exploratory data analysis. In the first graph, we can see that as we go from white-collar jobs to blue-collar jobs and from salaried employees to gig workers, we see the fraction of defaults are increasing. So it can be implied that job security is a good measure of potential repayment trouble. And we see a clear distinction in the range between defaulters and non-defaulters in debt-to-income ratio versus age graph. Non-defaulters lie in the tight range of 0 to 5 on the debt-to-income ratio axis. In the histogram here, we see that the fraction of defaulters decreases with the age. And from the last heat map, it is deduced that men are more likely to default before marriage. Going to the next slide. From the correlation matrix, it can be seen that the external credit scores and age are highly correlated with the target variable, that is the default indicator. And people who have been refused credit repeatedly have a higher chance of defaulting. Hence, the credit history can be seen as a good indicator to make decisions on lending. And going forward, we'll see the algorithmic implementation of feature selection and modeling, and the business strategy suggested based on the analysis done from EDA to data modeling.
Okay, now after doing data pre-processing and EDA, we go to the important part of the problem statement, that is finding important client factors and loan factors that contribute to loan disbursement decision. In other words, we need to find the important features in the data set which are contributing the most towards predicting the output. Here, the output is the target variable, which is binary in nature, where one denotes that the client is at high risk of defaulting. We have focused on two approaches to find important features, that is using weight of evidence information value approach and finding feature importance using gradient boosting. We can see from both the bar plots that the highest important features in both the cases are similar. External source 2 and external credit score 3 are the two top features in both WOE, IV and boosting method. External score are the score from external data sources. Some other features which made it to the top are external score 1, day's birth, which is basically an age, days ID published, etc. We did a lot of feature engineering and made many features. For example, we made new columns such as debt to income ratio. Also, in the history data, we found out minimum, maximum, sum, average, etc. of all the previous loans of a particular person. Now, we found feature importance using this new data, and we found out these feature engineered columns also made it to the most important features in the bar plot. New features such as debt to income ratio, the count of previous loans of a client rejected by the bank, and many such new features were important predictors of the target variable. And while making models, our accuracy also jumped from 0.68 to 0.77 after adding such new features in data. If we go to the next slide, please. Now that we have an idea of the important features which are contributing in predicting the output, let's now move on to another section of the problem statement, that is business strategy for lending decision. Here, I have shown a simple decision tree with a depth of 3. Here, the data is split based on the values of a particular feature. A very simple strategy is to start from the top of the tree and based on the questions asked in the node, go down left or right until we reach the base of the tree. Based on where we land on the bottom of a tree, we can decide whether the client is most likely to default or not. This looks like a very simple strategy, which is backed by a machine learning algorithm, but it has some drawbacks. In this tree, we can see only the 2 features, that is external score 2 and external source 3 are being used to differentiate a client. When we increase the depth of the tree, we'll see more other important features coming up. But how to decide which depth will help in differentiating defaulters from non-defaulters? We can use some robust methods such as random forest or other algorithms, but we cannot solely rely on these algorithms to make lending decisions. A better approach will be to combine domain knowledge of credit risk modeling with machine learning, which Aryan will explain.
Thank you, Varshit. Our strategy here is dependent upon distinguishing client profiles based on the analysis performed. We have seen that risk can be measured in terms of likelihood of default, and measures such as external credit scores are good indicators. We also see that often offers for loans and credit funding are ignored. Risk alone is not enough. Getting borrowers who are good for their money to avail credit from our organization is usually push-based. Thus, measures of propensity are calculated, such as count of refused loans in the past or frequency of required loans in the past year. These measures of propensity give an idea of the affinity of an individual organ or an organization to avail credit financing. A higher value indicates ease of initiating business. On a risk versus propensity grid, as shown here, we have factored potential borrowers into 4 distinct cadres. We have credit champs. These are low-risk, high-propensity loans which are availed readily. Risk is relatively low with a strong credit history. These customers should be given preference so that they remain loyal. Advantages like better rates, instant loans up to a certain amount without collateral, and priority service. Then we move on to seasoned borrowers. These are low-risk, low-propensity loans, and the average borrower lives here. They take loans usually to finance big life decisions. They have demonstrated credit history and meet their credit obligations. Competition is tough in this segment, and borrowers are often reluctant to avail credit. Aspiring borrowers are a category of high-risk and low-propensity borrowers. These are often first-time borrowers, and measures other than credit history are required to differentiate them. Customer loyalty from potential future customers can be gained in this segment by selecting carefully and providing the best experience. Then we come to risky borrowers. These are high-risk and high-propensity borrowers. These are risky loans, often collateralized and co-signed with high interest rates. These can be big money makers, but are risky, and only a relatively small percent of these loans should be provided. Decisions in this case should often be discretionary and on a per case basis. Moving on to the next slide. We've discussed the identification of defaulters and the features which are important for them via weight of evidence and gradient boosting as discussed by Varshit. And we have created various models on these features which help us in identifying the defaulters. Once we have identified the defaulters and flagged them, the risky borrowers which have been identified need to have collateralized loans and cosignees for their loans. Often their interest rates will be high as discussed. The risk reward payoff shows that a credit score threshold of 0.35 is a good indicator on whether a loan is risky or not. We also have some data sufficiency issues, which is a concern, as some of the best features which differentiate between good lending decisions and bad are external credit scores, and up to 56% of them can be missed at a given time in the data set. Effort should be made for analysis of our pipelines and to obtain data from more reliable sources to ensure that we have such features well in hand. This concludes our analysis of features of note, lending decisions, and recommended business strategy for OJAS financial services. Thank you very much. That's all from Team Data for Dinner.
So I would like to understand that finally the model that you have used is decision trees, is it?
No, it was gradient boosting, but for showing a business strategy, we made an example of using decision tree, like how one can make a decision. But
why have you used only gradient boosting GBM? Why have you not used other models?
Yeah, gradient boosting is the state-of-the-art method which is used for winning top competitions in Kaggle. So like it is one of the more robust methods. You can use random forest or you can use neural networks, but we went on with gradient boosting. Also, it offers a feature importance, like we can find feature importance after implementing gradient boosting. So that was one of the aim in the problem statement. So we thought gradient boosting would be a good method to go for.
No, okay, what you are saying is different. Feature importance is totally different and choosing a model is completely different.
Yes,
so you can always use cheap GBM for feature importance. Maybe you could use, I mean, there are other methods also, but you can use this also, select K features, whatever. So that is a different case. But why have you even tried using other models, or you just went ahead with GBM?
We started with decision tree just for taking like how decisions are being made, which features are more important. And later on, we moved to random forest and gradient boosting. We also tried neural networks, but that would make it more difficult, and finding important features using neural networks are a bit difficult. Like there are some literature available for that, but finding important features using neural networks is a bit difficult. So that's why we went on with gradient boosting.
It's not about difficult or easy. Okay, if you are taking difficulty as a criteria for model selection, what is your other criteria for model selection?
The model should be like it should be explainable, like what is happening, because neural network is kind of a black box, like you put an
okay, second point is explainability. What is the third? What are the different factors you are considering before finalizing on a model?
Timing should, like the model should not take a lot of time to like train, and so because neural networks and LSTMs, those models, they take a lot of time to train. So we thought like this would be another important factor before making a decision.
One of the more important things would also that we looked at would be the robustness of the model. Let's say in future more data comes in, and our model should not fail because once it has been deployed, people will be relying on it for their future decisions. So robustness of a model is more important, and we have tried to give that higher importance, sometimes even more than the performance of the model, because we want it to be consistently good, not excellent right at the very start.
What is your accuracy on trained data and test data?
So there was no test data. We differentiated the data which was given to us in 80-20 format, and like we found before feature engineering, we got 0.68, and after doing feature engineering, it was around 0.77 or 0.78.
And what is the accuracy of, let's say, by using this other random forest or some other model that you used?
It was 0.72, 0.73. So there was around like 5 to 10% increment after using gradient boosting.
So did you try hyperparameter tuning?
Yes, we tried hyperparameter tuning. Like we changed the number of nodes and all those things. So like we did some hyperparameter tuning, and there was not much of a success, because it was taking a lot of time, and so we tried some hyperparameters, but there was not much of a change. Like it went to 0.78, but it didn't increase after that.
And what is the difference between GBM and random forest? How are the two different?
Okay, so random forest is based on decision trees. So they use both are ensemble methods, and GBM is based on like they make weak models. Using weak models, they make a stronger model. Like starting with a weaker model, this may go with a stronger model. And in random forest, you take a feature, I mean, some part of the feature, some part of the data like bagging, and we make multiple trees out of it, and then we later on average the output of each of the trees. Or if it's classification, we find majority, like what is the majority of trees predicted.
Okay, Ashwin, you can ask. I think I have asked too many questions.
Not a problem. Hey,
Yeah.
fundamentally, like data for dinner. So what I wanted to understand is that, see, the current banking and service companies clearly facing a problem, right? Like, I'm not able to dole out enough loans, and I'm not able to collect them more, right? So already it is in the case that we don't have any kind of risk model in place, right? Now, in order for me to increase my loan book, I would have to cater to a different set of audience. Some of the features that you've used and some of them that you've highlighted seem to be of a customer of behavior that has already been shown in my company. But let's say that the target that is given to me is to increase the number of customers that I want to give out loan by say 10-15%, which is how do you think we should go about it, and which of the customer classification will my problem statement fall into?
Right, understood, Ashwin. So, first of all, the thing that we would like to highlight is that the section in which our problem statement should fall would be the aspiring borrowers and the risky borrowers section. What we want here is we want to go for a little bit of high risk situation because, like you said, we want to increase the size of our loan portfolio. And in doing so, we move on to, like you said, some of the features which are not very well established, like we don't have a solid credit history. So we move on to the very basics that we first discussed in the EDA steps. So like we said, there are certain factors like men before marriage are more likely to default, or that defaults decrease with age. Some of our other differentiating factors will have to take up the onus of prediction in this case. And thus we would be able to get into our various borrowers who are not yet customers of our organization. However, one thing I would like to point out here is that credit score is a especially good identifier in such cases and should be relied upon to understand your credit decisions.
But do you think credit score is available realistically for some of the new people? I mean, for the people who are trying to apply, or the size that you said that it's a risky borrower, aspiring borrower segment, right? Mm-hmm. Do you think that the credit risk score will be available to us?
That is a difficulty that we've also faced.
So if that's not there, which are the other features that you would focus on which can compensate for unavailability of the credit risk score?
Right. So we have various features, and I would say that based on our analysis, age, occupation type, how the income is being obtained, the region rating within the city for the client, education type, the region rating for the client, the number of days they have been employed, and past loan history, if any. If not, then that is also all right. These sort of things can be relied upon to figure out on a per client basis what the situation is. One thing that is very important is to figure out what the trajectory of a client will be, right? So if a client not only look at the client's current situation, but let's say, for example, they are highly educated and they belong to or they have a skill set which is highly in demand, or their business which they are acquiring loan for can be seen to boom in the next few years. These sort of decisions, as I said, would be best taken on a per case basis, and discretion of domain experts is always required in such cases.
Okay, so if let's say that 100 cases of loan application come to me using your model, how many cases do you think I can clear without any human discretion involved?
So out of 100 cases that we have, we are saying that about 77% of them we can identify with our model, right? As whether they are low risk or high risk. If they are low risk loans, we can go for a comparatively higher percentage of clearance, right? So out of 100 loans, let's say out of 77, we clear a high amount of loans. And let's say we have about 50 to 60% people being cleared in that segment. Then in the remaining 33% where things are a little bit dicier, right? We can say that we clear only a smaller percent. Let's say 5 to 6% of the loans can be automatically, let's say 10% of the loans can be automatically cleared from here, right? So we would expect an overall 55, 60% of the people that can be 55, 60, 65% of people that we can automatically take a decision on. And the remaining cases should of course be referred, because like you said, we are often looking at cases where we don't have enough credit history or enough information about our credit scores. And in that case, it's very much preferable to at least have a domain expert involved before giving the loan.
Sorry to interrupt, Aryan. Your time is up.
Understood. Thank you.
Thanks, team.
Thank you.
Thank you.
Ma'am and sir, let
Thank
us
you,
know
team
when
data
you're ready for the next presentation.
So do we have to go to a breakout room, or
No, ma'am,
we have to just
you can evaluate on your evaluation
okay.
rubrics and let us know
Okay.
when you want the other team to come.
Yeah, I am done with mine. So and
I'm done as well.
yeah, I don't have edit access to that evaluation, so I have just done it in my personal Google sheet.
Okay,
Okay.
ma'am, no problem.
Ma'am, we'll give you access right now.
Yeah, sure. Thanks.
Yeah. Okay, so the next team up is Team Neophytes. Could you please raise your hands? Or we can start with the presentation.
Okay. Good afternoon, everyone. We are the team Neophytes, and we are going to present our solution and framework for the loan disbursement process. Vaishnav, could you go to the next slide? That minimizes the associated risk and maximizes our opportunities. There are two datasets given. One is application dataset of the current client who is applying for the loan, and another is historical data, which contains previous loan applicant's history in regard to the loan application. In the application dataset, there are 122 features, of which 106 are continuous and 16 are categorical. Whereas in the history dataset, there are around 37 features in total, with 21 continuous and 16 categorical features. Using this dataset, Michael has to find meaningful insights for the loan disbursement process, developing a strategy for decision making that minimizes associated risk and provide an overall framework for OJAS banking services. We adopted a data-driven problem-solving approach by using statistical and ML techniques to identify the most contributing features for the target label in the dataset, and to accurately minimize default tests, we used decision trees, which was built using Gini criteria, and which gave good results for the confusion matrix, which we'll be presenting soon. Next slide, please. First thing is to study the nature of a dataset, for which we had done various explanatory data analysis and derived a few interesting insights for loan applications, which led to minimum risk. For continuous features, we could see the box plots gave good insights, like the denser population, higher scores from external sources, clearly increase the chances for client loan approvals. Similarly, for discrete, we could identify the most important features that describe the loan application status through these stacked bar graphs, where we could observe that the client, who is a repeater, belongs to middle yield group and applied for the consumer loan, having a higher chance of approval of the loan application. Next slide, please. Out of the exhaustive 160 features, our task is to identify the most important features contributing to loan approvals. For this, we did feature selection using ANOVA for continuous variables and chi-square for discrete variables, basically studying the variance of individual features and selected those features which explain the variance of our target variable the most independently. Using these results, we also grouped a few highly correlated continuous features together to derive a better insights. So from 160 features, we selected 23 clusters, 32 discrete, and 45 continuous. Here the bubble chart shows the clusters and the size shows the relative importance, which was according to their ANOVA scores. Next slide, please. Once we identified the important features, our major task is to use appropriate tools to derive useful information. For category features, we had three important measures. One, the confidence of approving a loan application. Two, chances that the client will refuse the loan after approval. Three, chances that the client will be a defaulter. And each feature and each parameter were calculated using Bayesian probabilities in following manner. Like one, the joint probability. For example, probability of approval when the client has applied for a cash loan. Two, condition probabilities for the refusal, like probability that the client probably it has been applicant has been refused, provided the client has applied for the cash loan. Three, joint probabilities. Example, probability that when a client has applied for cash loan, that he will be a default or target as one. So the snapshot of the tool is given in the box, like where the user will input these data categorical features of the application, and based on that, three output metrics have been calculated, which could be shown the percentage applicant, expect chances, and everything. Similarly, for the ratio variable, we use ANOVA scores to make the correlation clusters, and the exhaustive list has been shared in the appendix. Next slide, please. So now, before building a Bayesian model, there is a problem with the data set, that is data insufficiency. So to make it more uniform and balanced, we randomly selected 50% features from the non-defaulters basket and 50% features from the defaulters basket, and targeted more in predicting accurately the defaulters, which are reflected through our confusion matrix, which could show the precision was around 85%, recall and accuracy is around 76, and the score is around overall score is around 85. So by this decision tree, we'll be able to identify 85% of the defaulters correctly, and only 15% of the identified defaulters might be non-defaulters, thereby not losing much in the opportunity zone. A snapshot of the decision tree could be seen here, and using this, we had derived key insights and we made a framework which we presented in the next slide, please. So based on the decision tree classification, we have classified both the discrete and continuous variables. We found that the approval of the application is higher when the external scores are high, and the nature of the occupation and the education, whether the guy is a repeater in taking loans from the same, and apply for a type of the loan, consumer loan, whether its payment is through cash or the profile is POS, the product type, the channel through which, and the age group or the yield group, and the purpose of the loan as a category based on the occupational electronics and all, whether the guy is living in high status region or not. Similarly, we have found that for disapproving the application, the disapproval of chances are higher if the client is frequently changing his phone numbers, changing the application forms, and the goods price of the purchase is relatively lower. And similarly, we could as well target the customers from the occupation type, like if we target the consumers having high electronics, coming from the electronics background, highly educated and family status, having a car, occupation type, high income, and living in a posh area. So in summary, in a gist, we could see the below top customer features to scrutinize while giving loans to target for good opportunities. Next slide, please. So based on this overall insights, we made a key framework like decision-making strategy, mainly focused on opportunities and risk involved in the process. Using decision tree analysis, we come up with a similar to BCG matrix in which two axes represents the opportunities and risk, and we have segregated the important features based on the nature in these four quadrants, where each quadrant signifies its own importance. For example, stars, where it is having a little lower risk and higher opportunities, and you can see the question marks where we could see the high risk and high opportunity. Similarly, the cash cows, like they are little lower risk in lower opportunity, both where we can just milk the opportunities. And similarly, the fourth quadrant, the dogs, where you could see the high risk and low opportunities. So we have found 19 important scenarios based on from the data set that will affect our loan disbursement process and are represented in this matrix. And we could study each, for example, in each quadrant we could see, for example, in stars, we could see the information from the relatively from external sources are relatively more important while taking the decision. And similarly, in kind of high risk and high reward question mark, we could see the background of the applicants, like from which region is coming from, what type of loan is taking, cash loans and everything, the previous applicant, the client's previous application status, and his cash portfolios. Similarly, if you want to stay low, I mean low risk and low opportunities, kind of we just want to milk the opportunities, then we could see whether we could see based on, we can take our decision based on just whether it is coming from a well-developed livelihood, and the more loan amount is applied previously and is approved. Okay, these are a few factors which we see. And similarly, for the dogs category, where we're having high risk and low opportunity, we could just see whether the applicant is changing his applications frequently, its past data history kind of, and how frequently is changing his mobile numbers, and whether the client has provided his emergency state contacts and details, and from which group is coming, whether it's belong from a non-normal age group. So this is kind of overall framework and strategy we have been provided for the OJAS banking and services. So thank you for this opportunity, and that's all from Neophytes.
Thank you. We are up for Q&A now.
So hi team. So I wanted to understand from you, why have you zeroed down on decision trees, and what is the metrics you have used to zero down? Is it accuracy? Is it something else?
Okay. Take it.
The first thing is the decision tree is more interpretable, ma'am. So, and we can also incorporate categorical variables and continuous variables in the input. So we choose decision tree, and we can actually tune the some of the parameters, like we can actually use entropy or Gini index for the optimal criteria, and also we can actually change the decision tree, like the decision model, by changing the data. So
why not XGBoost random forest then? It's the same, right? But with the better performance. Have you even evaluated other models, or you just zeroed down on this one?
zeroed down, but like we don't know about gradient boosting much, so we didn't implement it.
But this one why we went more towards, because we know we want to accurately predict the defaulters. You can go to that matrix, completion matrix. So we want our target is clear. We have the discrete variables and continuous two sets of data set we have, and we want kind of easy classification. And we want to target our prediction, our accuracy more towards the defaulters. So we want a model which we could control more of our conversion matrix. True positive, I mean, we want to accurately predict. So based on that, we have designed our model, and we could see our results.
And you said that you have, okay, I understood your point. So you said that you have taken 50% defaulter data, 50% non-defaulter data at random, because it's imbalanced data set. So don't you think you could have used a more scientific way of, I don't know, taking both the classes, because there are proper scientific methods, because it's not necessary that whichever data set you chose, right, that is the correct one. Because I don't think you have followed any sampling techniques.
Yeah, sampling. We use random sampling.
Yeah, it is random. So obviously it's not going to be that accurate, right? It's not necessary that it will be very representative of the entire population.
Yes, ma'am. Like we have taken the data is like around 10,000, like 1,500, something like that. Total number of the data. Use it for decision.
No. See, you could have taken all the data from a single city itself. It's not necessary that it's going to be representative of each and every. It's not necessary it will be actually representative of the population. So anyways, just Google oversampling, undersampling. Okay, for future, you should have used that instead of this. And also this last slide, right? The cash cow opportunity slide that you had. So I am just thinking that you have taken two, like one is risk and one is opportunity, right? So do you think this is the better way of representing, or do you think if we can represent like where can we make more money, or where is the risk of default less? So are you very sure of the X and Y axis for dividing these categories? That's what I want to know.
Actually, opportunity indicates where we can make more money, ma'am. That is what our
I would like to add these points, 2 points actually. Before
Okay.
the sampling one, and actually we have did multiple iterations in the sampling data set randomly taken through Python packages. And in each iteration, like we have seen the different iteration and the score is not changing much, accuracy, the pattern and all. So this is kind of thing which we're getting for 50%, 50%. So this is one point I just want to add this in. And the second question followed, Vaishnav. So in this, like as you stated, ma'am, like we have actually focusing on that only. The cash cost shows that relatively less amount which you can derive the money. The stars which you see the opportunities where you can derive maximum cash from the scenarios, given scenarios. And the question mark is kind of a risky zone, kind of a dicey area where little higher risk and higher opportunities are there. Is regarding the amount of cash which you could derive, the dogs, cash cows and all.
Okay, I think I will stop now. Ashwin can take up.
Yeah, can you also move to that recommendation slide? I wanted to actually ask you this. I want to deep dive on one of these. You mentioned that someone who's recently changed their phone number classifies as someone who has, someone with lower opportunity and higher risk. I want to understand, why do you think that's the case?
One is like its score. I mean, from the ANOVA score, the variance of this particular feature and the variance of the defaulter is correlating very high. It is expelling more. There's one highly correlated, so it's in high correlation with the defaulters. That is one thing which we have found from the data set.
Okay, but in general, do you think that this is a risky parameter? Let's say that you've gone to apply for a loan and say that I just changed phone number because I changed the city. Do you think that it comes under the realm of something risky? Like you followed your analysis, but at the end of the day, do you think that this recommendation fits in this category?
Yeah, I mean, we are not straight away rejecting the application. Like these are the features. These are the features we have to scrutinize, and this will give us some kind of weightage while deciding at the overall whether to give him, to approve for the loan or not. So it's kind of one of the contributing thing, but not the deciding factor.
Okay. So I wanted to ask you on, so assuming that, you had access to data outside the data set that you had, what do you think are the top two data sources you would need to, increase your accuracy more?
So additional features which we are, if we got available, then our model accuracy will increase. That's what you're asking, right?
Yeah.
It could be maybe the income basket, like the ranges of the income or the financial, more obviously CIBIL score and financial history, more of financial history would be helpful for us.
Okay, financial history.
Yes.
Okay. Yeah, that's all.
If the credit score of a client is given, then it will be beneficial for us to evaluate on the basis of credit score, as there is only one parameter that is indicating about whether the client is defaulting or not, or whether he has payment difficulties or not. So if there are some more features which indicates the default, whether the client will be defaulter or not, so it will be beneficial for us.
All right.
Thank you, team. You may please. You have any question?
No, I'm just thinking, are you sure that credit score is not given? CIBIL score, credit score.
There is some external scoring was given, and external agencies ratings were given.
The actual credit score, which for every person it is evaluated, right? It's not given in that data.
But yeah, okay. Basically it's kind of financial history we want. We want more. that is
Got it.
reflecting less. More of
Okay.
app data and all is given.
Mhm. I think we are done.
Thank you, sir.
Okay,
Thank you so much.
thank you.
Thank you.
Thank you, team neophytes. Ma'am and sir, please let us know when you're ready for the next presentation.
Yeah, from my side, I have scored.
I'm done as well.
Okay, so inviting the next team, Team Datafly. Can you please raise your hands and prepare yourself for the presentation? Ruma, you can put your hand down. You have all the team members here?
Yes.
Okay, you can share your screen.
Should we go on? Good
Yes.
afternoon, everyone. I am Rakshit, and I have my batchmate Shubham with me. We are from Team Datafly, and here we are to discuss our analysis on the problem statement regarding loan lending decision making. So the problem statement involved OJAS banking services, and they were facing some issues regarding loan lending decision making, and they want to minimize the risk associated to that. During this application process, the bank actually collects a lot of information from the clients, clients' income, occupation, education, lifestyle, and various other factors. All this to know the client better so that they can make a sound decision. And apart from this, they also collect some external information from some financial institutes like credit bureaus, and also carry on some background verifications. On the basis of all this information, they try to make a decision. If the client satisfies their criteria, then only they provide a loan to the client. But in spite of having so much verification and so much data collection, it is observed that some of the clients face some payment difficulty. So it is necessary to do some kind of data analysis on previous or current loan applications in order to gain some key insights, hidden insights that can link some features, some factors directly to payment difficulty so that the bank officials can make better loan lending decisions. So we were provided with two data sets. The first one was related to the payment difficulties faced by the clients and the current applications. And the second one was related to their old or previous loan applications and their status. So based on the features available, we divided them into two major categories. One is the client-based factors and another one is the loan-based factors. We further divided the client-based factors into occupational factors and the demographic factors, while the loan-based factors was divided into active and previous loan factors. We did some data pre-processing on the data available. We eliminated the outliers, and post that we did exploratory data analysis to come up with some key insights that link some of the features directly to the payment difficulties. And on that basis, we attempted to predict the loan lending decision that can help the bank officials to make a sound decision. So here we come to few key insights. So here on the left, we have plotted a pie chart of defaulters versus non-defaulters. And we observe that the number of defaulters in our data set is extremely low. It is around 8% only. So this means basically the category for which we want to know more information is not available to us, it's less. And due to this high imbalance, we will have to take some extra adjustments during the modeling phase so that our model predicts good results. On the right, we have plotted client's loan type with the default rate within each category. So there are two types of loans. One is cash loans and the revolving loans. So we observed that for cash loans, the default rate was high as compared to the revolving loans. And this can be attributed to the fact that in revolving loans, clients first have to repay their existing debts and then only they can avail extra debt. So naturally, the default rates are less. Now coming to the demographic factors, here we have plotted clients' housing type. The top two bars are related to the clients who live in rented apartments or live with parents, and they showcase higher default rate as compared to the other categories. This can be attributed to the fact that the clients who don't have own property may be having some kind of financial instability, and that's why they are having higher default rates. On the right, we have plotted clients' region where they belong from. And here we can see the tier 1 region is having a lower default rate as compared to the tier 2 and tier 3 region. Now coming to the client's family status, here we have the top two bars are for clients with civil marriage or who are unmarried, and they showcase higher default rate, which is around 10% as compared to other categories. On the right, we have plotted the client's family members and the default rate within each number. I mean, as this basically indicates that as the number of family members increase, the default rate is also increasing. And here for our data set, we observed that for 11 and 13, the default rate is actually 100%. Now, coming to the client's education, here we can see as the education level is high, the default rate is quite low. Whereas for lower education level, the default rate is quite high. This can be attributed to the fact that with higher education, there is more financial stability, and that's why lower default rate. On the right, we have plotted a density distribution of among the defaulters with respect to their age. And we can see as the age bracket is increasing, the number of defaulters is reducing. This can be attributed to the fact that with the higher age, there is more financial stability in life, and that's why there is low default rate. Now coming to the occupational factors, here we have plotted the default rates for various categories of occupation, and we can see there are two different categories here. All these job types, occupation types are having similar default rates, while this is another category. This includes IT staff, HR staff, core staff, managers, and all the white collar jobs, which are having less default rate, while these include drivers, security staff, laborers, cooking staff, sales staff, which is more like unstable jobs, blue collar jobs, and that's why they are having a higher default rate. On the right, we have client's income type. Here, what we have observed is for businessman and student, the default rate was actually 0 in our data set. And this basically indicates it's better to provide loans to these categories. While for the unemployed, the default rate was around 35 to 40%. Now, Shubham would be taking up the business recommendations.
Yeah, thank you, Rakshit. Now, based on all the insight that we got in the previous slide, we can get an idea about the important feature in each of the factors. Firstly, we saw the loan factor. Here we saw that how loan type can play an important role. Now, besides the loan type, we have the data available we have clients' past data available, like what are the past loan status, their amount, or their due date, means the past loan have been terminated or not, which can also play an important role. In the demographic factors, we saw that how client's age, his education, his family members or family status, his living condition will play an important role when making a loan lending decision. Lastly, in the occupation factor, we saw how the people with the unemployed people or people with a blue collar job or unstable job have comparatively higher default rate, and the people with HR manager or white collar people, or IT staff, or students, or businessmen carries comparatively less risk while loan lending. Now, these were the insight we got from the sum of the feature. In the complete data set, we have over 120 feature in the current application data. Plus, there are 30 more features in the historical data, which is related to the past data. Now, it is very difficult to come up with the certain criteria based on only few features to make a loan lending decision. Now, here's why the machine learning model comes in. Machine learning model can help us to make a better loan lending decision. Now, I would like to discuss some steps to build a machine learning model. First, we have to extract the key information from previous loan history, like how the previous loan status is active or not, what was the amount in the previous loans, and combine it with the current application. After that, we would like to do some feature engineering method, like combining or reducing some of the feature to so that the less computation time will be allowed. Or like Rakshit mentioned in the earlier, that we are dealing with here high imbalance data. So we have to come up with the sampling techniques like undersampling, oversampling, or SMOT so that the imbalance data can be better handled and our machine learning performance can be increased. Lastly, we also have to consider a case where the past historical data for particular client is not available. For that, we have to come up with a different machine learning model, which will be completely based on the current application data. Now, considering all these features, we have tried to build a similar simple machine learning model based on the current application data and historical data for each client. We believe that this machine learning model can improve the loan disbursement decision for OJAS banking. Thank you.
Thank you.
Sorry, yeah, thanks a lot for your PPT. So what is the machine learning model you have finally used? I did not understand that.
Yeah, so I think we are more focused on the analytics part and getting the insights from the data. But considering the number of categorical features we had in both the main application data and the historical data, we have chosen to use categorical booster, cat boost algorithm, because it can handle the categorical variables better. And
Okay.
we have only chosen we have built the simplest machine learning model that will have minimum missing values or easy imputation. Like we have chosen based on that from our current understanding.
So you think cat boost can help you with missing data?
No. I am saying that we have built the simplest machine learning model. We have selected only the feature we can easily impute, which are there are not a lot of there are no missing values in that. Means
okay, in the PPT I cannot find any cat boost anywhere, so I think it's mostly feature engineering and visualization that you're focused on. Okay, and how did you balance the data? You said it is imbalanced.
We tried both the methods, oversampling and undersampling method.
What do you mean by oversampling?
Oversampling,
what
like
is oversampling?
we have let's say we have we saw that we have only 8% of data for defaulters. So what we will do is like we will repeatedly take after setting aside the testing data from the training data that we have, we'll repeatedly take sample for defaulters to increase
you will take how, based on what?
With replacement.
How will you do that? I'm not able to understand. How will you do that oversampling?
Oversampling, let's say we have 100 data related to not defaulters and 10 data related to defaulters. I will repeatedly take that the defaulters data, I will duplicate it to train the model. Just to train the model, I will oversample it because the number of points I have available related to defaulters is less.
Okay, that's not oversampling, but okay, no worry, just read about it when you have time. And also one more recommendation that I wanted to ask you was students should be given loan because they do not default. Are you sure of that recommendation? Because it's a tall claim. They don't even have income, right? So yeah.
That's why I mentioned like it's very difficult to come up with only certain criteria that will give me loan lending decision. So based on what data we have got, we have found that all the students were in my data, they had 0 defaulted. That's how I wanted to mention that how the data we have got is such that all the students, I don't find any defaults in there. So
Okay,
that won't be the case like in reality, or I will give student loan to all the students. That's why I mentioned like we need to consider other factors also, which won't be possible by just analyzing the data. We have to use machine learning.
no, it's not about machine learning. It's also about, let's say, whenever you're mentioning such things, right? Like people who are on maternity should not be given loan, students should be given loan. So
Yeah.
these are very contradictory. I
Yes.
can't. I mean, they're very controversial. First of all, some of the maternity part that you just said, and the student
Yes.
part is very counterintuitive. So you might want to give more information that in this data set only 10 we had 10% student and their average income was this much, and average loan size, it might be that the average loan given was very less, right? So you might want to be more nuanced
Yeah.
wherever you are
Exactly.
quoting something very, very counterintuitive or very, very controversial. So that would be my feedback. And if you haven't used something, then don't like say it. So if you're sure about a technique, only mention it then. So yeah, now I think Ashwin can take up.
Yeah, I also wanted to sort of give that feedback that sometimes you can also use your intuition to see, if some of the recommendations make sense. One thing I wanted to sort of ask you, I remember in your first or second slide, you mentioned that the applicants in tier 2, tier 3 cities possess more risk, right? And then there was you also made an insight that people who stay in rented apartments are at more risk. Isn't this something not tallying that tier 1 people are less risky, but it turns out that tier 1 people probably live more in rented apartments?
So
Can you go back to the slide?
yeah. Yeah, so it was observed, like we considered only one feature while deriving this insight. So there may be some other factors associated with that as well. So we haven't considered that while plotting
Can
this
you
graph.
can you say some of the other factors? I mean, what is missing in this? What is missing in this data that is sort of giving you this insight?
So we haven't linked the occupations of these clients who live in this tier 1 or who live in a rented apartment. We haven't linked the occupation of them. We haven't linked the age with these clients, and that's why we can't say much about that. We are just making this claim based on just one factor at this point, not involving other factors.
Okay. I had one more question. You mentioned in your insight recommendation that we should give loans more to revolving loans, right? Assuming that the company strategy is that I want to give cash loans to blue collared workers. What do you think are the top 2-3 features that I should look at to take this decision?
I would say job stability. We will have to look at the occupation type. We will have to look at the family status, the education level, the income level, and also its demographic factors.
But these are blue collared workers, right? Will some of the things you said make sense for them?
Yeah, so they are having unstable jobs, but still we can check like how skilled they are, and doing some background checks, we can know like whether these clients are having some good skills or having some stable jobs and making some enough income so that they can pay the loans in time.
All right. Okay. Yep, that's my side.
Thank you, Team Datafly. You may please stop sharing your screen. And judges, do let us know when you're ready for the next presentation.
Yeah, I'm ready.
Yeah, you can continue. I'll be ready in a few seconds.
Okay. Next, we have Team Mahalanobi's disciples. Please raise your hands and share your screen. You may start now.
Good afternoon, everyone. I am Shambhavi Singh, and we are Team Helenoble's disciples from ISI Kolkata. Today, we are going to present some insights and recommendations on the case that was allotted to us on loan disbursement, wherein we'll cover various factors about our understandings, like why there are defaulters, and on some categories on how we can mitigate or lower these rates and improve bank profitability. First, we would like to touch upon some of the trends in defaulters based on various categories like demographics, type of loan, income band, etc. An important point to note over here is that in application data set, which we had received, the average default rate is around 8% out of 3 lakh applicants. So now looking at the graph on the left, we have plotted income type versus the number of customers. We can see that in the first 4 categories, the blue bar, which represents the defaulters, is quite high. The absolute number of defaulters in these categories is very high. Also, we see a pretty similar trend in all of the categories, except for 2 categories, student and businessman. We can see that the overall category for student and businessmen, as such, the volume is quite low, and the defaulters are also not negligible as compared to other categories. Moving to the next slide, moving to the next graph, we have plotted gender versus customers, number of customers. So we can see that the number of females applicants is quite high compared to that of males. And also the default rate of males is higher, which is 10%, which is very much higher than the 8% rate of the average applicant data. So here we see that in the females, the default rate is only 7%. In the next graph, we have plotted loan type versus the number of customers. So in the revolving loans, this value is also very less. The number of applicants here are less. And also the average amount of loan, which is in case of revolving loan, is around only 3.25 lakhs. Whereas in the case of the cash loans, it is around 6 lakhs. So we can say that the lower value of loans and also the high repeating frequency of these loans puts them into a criteria where they have lesser default rates compared to that of cash loans. Moving to the next slide. Here we have plotted income band versus the number of customers. So it is quite obvious that the people in lesser income bands would have higher default rates. And also they have higher number of applications. In the next slide, we have plotted occupation versus the number of customers. So we can see that as in the categories of labor, salesman, and the sales staff, the defaulters are higher. We have around 10% to 9% of defaulters in these categories, which is marked by the pink stack. Also, we have a very high number of unknown data type, which is shown in the first tag. So our question was like, why if occupation is playing a significant role to predict the disbursement of loan application, why was this loan provided at the first place if we don't know if we don't know their occupation type? Moving to the next slide. Here are some factors which are improving the approval rate. So we have plotted customer type versus the number of customers. So we can see that in the case of, we have around 18% of new to bank customers, and which is very less compared to that of 73% of existing to bank customers, which is shown as repeater over here. And also the approval rate is quite high, around 93% for new to bank, and which is only 53% for ETB, that is the repeater customer shown in the blue color. So with higher approval rates in NTB customers, ideally banks should be targeting more of new customers, which would result in higher disbursement of loan. Also in the orange color, we can see that around 24% have been cancelled, even though being a repeater customer. So this in a way represents a lost opportunity to the bank. So it could have been increased by increasing the approval rate. In the same regards, towards our right side, we see we have plotted channel type versus the number of customers. So here also in countrywide, stone and regional local channel type, we can see that the approved percentage, which is shown in the blue star, that is quite high, which is greater than 80%, compared to only 40% in credit and cash. So the focus should be on increasing the capacity of countrywide and stone channel. And also the orange color, which is shown, that is 39%, is cancelled. So even the effectiveness of credit and cash could be increased. Now I would request Mayank to present some more recommendations on this.
Thanks, Shami. So one of the recommendations that we would be suggesting to OJAS banking and services would be that they target upsell of loans to students. If you look at the graph which shows distribution of application defaults over income type, we can see students and businessmen have low application volumes, and we have very negligible defaulting rate there. Now, students as a subcategory is of a particular usefulness to us because we feel that they're under targeted by the bank. Now, if you look at the other graph, which is the distribution of application default over educational qualification, we can see that the rate of defaulting among applicants with higher education is 5.36%, significantly lower than the overall average of 8.07%. Now, the way we are trying to connect between these two graphs is that these students have a potential of being converted into applicants with higher education in future, and which is evident and as evident by the defaulting average, which is very low, maybe because of some sort of behavioral characteristics. So it makes sense that we upsell more loans to these people because one, their rate of defaults might be low in future, and two, we can safely cross-sell them other loans in future. So that's what we are recommending here, that we target upsell loans to students. And if the way we can do this is we create some sort of a academic portfolio for the students so that we can target the most meritorious students so that they can complete their higher education and they can come up into that bracket. That would help us, that would help bank increase its profitability. So I'll now ask Roshan to continue with the other recommendations.
Sorry, I wasn't. Yeah, thank you, Meg. So here in this slide, what we're trying to do is trying to highlight the ineffective cross-sell strategy of the banking solution. So what we have noticed that in our data sets, around 8% were the defaulted applications, which were somewhere close to 24,000 applications. And when we have a look at the past history of these applications, we have noticed that these applicants, there were 29,000 applications were applied by these 24,000 customers. And these many were rejected in the past. And out of these 29,000 applications, we can see from this particular pie chart is that around 58% of these applications were rejected because of the reason of high credit, which is directly proportional to the affordability of the customers. And when we further drill down into how these applications were sourced, we see that the 48% of these 58% were actually a cross-sell application. So if I try to connect the dots here, what we are saying here is the applications which are defaulted in the present already had a history of multiple rejection in the past, and that too because of the affordability. But the more contrasting thing is that we were trying to cross-sell them their product. So we are trying to approach customers, cross-selling some of the products, and then we are also rejecting the application because of the affordability of the customer. So that is a contradicting part here. So what we can do here is we can have a look at the monthly snapshot end of the balance, which is not present in the data. So these are the additional data sources we would need so that we could have made a better judgment in order to cross-sell any product to the new customers or even in the existing customer, because majority of the customers are already banking with us. So we will definitely have the month-end snapshot and the behavior and other aspects. So we can have a look at those score before suggesting any cross-sell. Another recommendation which we have here is the weak pre-book fraud strategy. So what we have noticed that out of these 8% defaulted applications, we have already discussed that most of them were already rejected in the past because of some XYZ reason. So what we have noticed that out of these rejected applications, around 13% of the applications were rejected in the past because of the fraud score. And how we are saying that the rejected region was SCOFR. So that is why we are saying that these applications were rejected because of the fraud in the past. And if we look at the distribution, how these applications were rejected, we can see that on an average, around 50% of the applications were rejected around twice, and at least 2 bureau calls were made in the past for these applications. So what we are, if we summarize this thing, what we are saying that around 50% of the applications which are defaulted right now have a fraud history in the past, and we had made around like 2 bureau calls for those applications and around 1 fraud rejection for those applications. So in spite of doing all this scrutiny in the past, we are approving these applications and later they are ending up as a defaulted application. So as a solution, what we are proposing is we could have a look at the repayment history of these applications, because most of them are already banking with us. We can have a view at the month of by end end of month snapshot. What are the balance they are maintaining in their savings account and other. We can have a view at this bureau score, behavior score, and the debt to income ratio. We could also have a view on the social media behavior, because most of them are rejected because of the fraudulent behavior. So we could have used big data technologies to identify their behavior on the social media, because most of the fraudulent customers tend to either have no digital footprints, or even if they have a footprint, we can find some sort of patterns in the data. So yeah, that's all we have.
Yes.
Thank you.
Thank you. Thank you.
So team, I mean, I would really like to appreciate your business recommendation and visualization. Excellent job there. The only thing I am I want to ask, you haven't used any model as such, right? Overall, you have suggested that we have to build the model, but I mean, that's the only thing lacking, at least as far as I'm concerned. Any thoughts on that?
Yes, ma'am. So the idea was to focus mainly on what's the wrong with the current system. So with the given set of data sets where we are actually lacking, and we had tried to mainly connect the dots, because if there is a region 1 and there is a region 2, how can we connect these 2 regions? And then based on an overall basis, not getting into the detail of the model or mathematical aspect, from the business side of the problem, we tried to address the problem. So that's why we did not get into the model aspect of the problem here.
Okay, I mean, I'm not sure if that was an expectation to, build the model or not, but I think it was. But overall, yeah, I mean, I don't have much to ask. So you can ask Ashwin if you want.
Yeah. Since you've sort of, analyzed this more from a business viewpoint, right? Could you rank order for me the order in which we should implement these business insights?
Sure. So first thing was definitely on the this fraud call, because when we actually had a look at how these applications were getting defaulted in the present data, and when we actually look at the past history of these applications, we noticed that as we have already mentioned, that for 24,000 applications, the rejections was somewhere close to 29,000, which basically means I'm rejecting almost every application in the past. Then what has changed in this duration that I've approved those applications presently, and now they are getting defaulted. So this was one of the major criteria. Another, this would have been the rank 1, I would say. The another was the fraud criteria, because once we have rejected anyone with a reason of fraud, how can again I approve those applications, and we are seeing that these applications are again getting defaulted in the present. So that would have been our second order. And then the third one would have been upscaling the student loans, because once these students graduate or have some higher education, we already see that the default rate is very less, only 5% compared to the global average of the population average of 8.3%. So that would have been our third.
So your first one was to improve the cross sell, is what you're saying, or the fraud was the first one?
Cross sell.
I did not actually understand.
Cross sell was the first one, because we are already reaching out to the customer, and then we are already rejecting them because of the affordability only. So that does not make any sense.
And one more thing I had. So you mentioned that fraud is something that you would solve for, right?
Yes.
Uh, can you tell me, for people who end up being fraudsters, right? Uh, what is the data that you would look at, given that everyone looks at these risk scores, etc., that is there, but the people who end up doing fraud are mostly because of activities that where they do not leave a fingerprint. So what is it that you would do? Do you think that this percentage of fraud is an inherent risk that this industry already has?
Uh, Definitely. So there are multiple kinds of fraud which are happening with the banks, like pre-book fraud and the post-book fraud. So we are mainly concerned about the pre-book fraud because we wanted to identify, scrutinize this customer during the time of origination only. So what we can have a look at is the number of months the person has been staying at a given address, or the number of months he has been in a given job, or the number of times he has changed his phone number in the past. So these are the one of the parameters which we can have a look before judging them on the fraud scale.
What was the percentage of applications that was rejected due to fraud? If just in terms of
13% of the
and in terms of overall numbers, absolute numbers, what would that be?
Overall number, it would have.
There were about 24,925 applications that were defaulted.
24,000 was defaulted, right?
Yes. There were about 3 lakh something applications, out of which 24,000 were defaulted.
And due to fraud, how much?
Due to fraud, somewhere close to 3,000 were rejected out of this 24,000 applications. So that will goes down to 12% or something like.
3,000 is what you've attributed to fraud. Sorry, your voice is breaking, which is I'm asking. Yeah. So on one hand, you had the whole student loan and upselling, right, which will obviously increase the size of my loan book, and on the other side, there is a 3,000, just a problem of size 3,000, which you have ranked 2. On light of these numbers you have provided, do you think your rank order might change in terms of the way you would implement it?
No, because the amount of loss generally the financial institution loses from the fraud part is significantly higher than the amount, the value which would lose by giving loans to the student. So the fraud would still be the rank 2, I believe.
Also, I think because upselling of those loans to students would take a longer time, we have to market those loans to the students, pick up the correct category. So we would prefer to put it in the 3rd place and put cross-sell above them.
Got it.
Thank you, team. You may please. Are you still left, Shelja?
Yeah, I'm done.
Okay, thank you. Team, you may please put your hands down. And judges, let us know once you're done.
Yeah, I'm done.
Ashwin, let us know once you're done.
I'm done.
Okay, thank you. Next up, we have team outliers. Could you all please raise your hands? You may share your screen now. We can start.
Good afternoon, everyone. I, along with Shivam and Abhinay, represent Team Outliers. So today we'll present our insights and analysis on the problem, and we'll also look for a solution. So let's start with the presentation. Next slide, please. We'll start with the problem statement. So the problem statement was to deliver at minimum the client factors and the loan factors that contribute to the loan investment decisions of OJAS banking and services. Also, we had to propose a comprehensive framework for taking these lending decisions. We were provided with two data sets, the app data that has all the information of the clients which are available at the time of applications. And along with this, we had the history data containing information about clients' previous loan data and whether the previous application was approved, cancelled, refused, or unused. The approach that we have used to factorize the loan eligibility is to divide the loan eligibility into three broad spectrums. The first one is the willingness to pay. The second one is the ability to pay and the verification factors. For willingness to pay, we assume the presence of other liabilities and past credit history, and also what is at stake, things at stake as the most important identification factors. Similarly, for ability to pay, the assets of the client, their qualification, and the employment status have roles to play in it. The issues with the data collections for the ability to pay includes data availability issues, partial disclosure on the side of the applicants, and data normalization issues as well. For the verification factor, we can use the ID or the forms and can also analyze the personal details or personal factors of the clients or the individuals. So the issues with the verification factor here includes the data integrity issues, the data availability issues, and also overall it's a more time consuming process. So we'll look at each of these factors in details. Next slide. So the most important factor for us is the ability to pay. To understand the ability to pay factor, we'll perform the analysis on the following features. The first one is the occupation default risk. We plot the graph of the number of defaults observed based on the occupation of the client. And as evident, it was very clearly visible that low skill laborers are at the highest default rate, whereas accountants or white collar job individuals have a very low default rate. Similarly, for qualification, people with lower secondary education have higher default rate as compared to those having academic degree or higher education. So basically, by looking at these plots, we can optimize in these categories. Maybe a more rigorous inspection while providing loan in categories that has higher default rate at present. Next slide. Going ahead with the ability to pay conditions, we continue our analysis and analyze the following features. The first one is the income range. People with a very low income range have higher default rates for obvious reasons, and therefore they are at higher default risk. So to compensate for the risk, maybe additional interest or guarantee may be asked by the bank. Similarly, for the employment type, we can see working and state servant have the high default rate compared to businessmen. The low default rate for students and pensioners represent there are already optimized loan conditions in place by the bank, or maybe they are being offered, the number of the loans that are offered at are very low to provide a meaningful insights out of it. We can also see that for employees with maternity leave, with employees on maternity leave, and also others, we can see that there is a very high default rate. But this is due to the small number of observations on this category, and hence they can be ignored. Also for the loan, the loan can be offered in the form of revolving loans and cash loans. Now, the revolving loans are at a lesser default rate compared to cash loan, and this is pertaining to the fact that revolving loans have a stricter scrutiny, and the loan amount in revolving loan is low compared to cash loans. So that is the reason for those. And in the credit range plot, we can also see that the plot suggests mid-level range of credits, which is around 3 to 6 lakh. They have the highest default rate, and hence these section of loan amount need special attention. Now, the reason for the high default rate could be that the larger amount of the loan requires additional financial backing by the bank in the form of securities or jobs, etc. of the client, and hence there the chance of default is low. And low amount of loans are generally too small to go under default. Therefore, the loan amount of 3 to 6 lakhs are at the highest suspectable reasons, and they require special attention. Next slide, please. In willingness to pay, the willingness to pay is a very subjective thing. We understand that, and we have included the gender and the housing type. So for gender, we have seen that female are generally more diligent and more willing to pay loans and prevent defaults. However, men, they have a higher default rates. For housing type also, people living in rented house have no security at stake, and they are at a high probability to default compared to individuals having their own house and as their guarantee. So that is somehow affects the willingness to pay. And the third factor, if you can move on to the next slide, is the verification method. Now, this is a very important factor in this case. This is generally seen that individuals having not so legitimate verification have high chances of being fraudulent and are at a higher default rate. For example, the two box plots that are shown, the two box plot shows that those who have the recent published IDs, they have a higher chances of default. They have higher default rates, the red box. And also the individual factors like age and employment tenure have also a role to play in this. Young age individuals have higher chances of default. The mean age of defaulters are slightly lower compared to other applicants. Similarly, tenure has also a role to play in this. We can see that median employment tenure and also the quartiles of the days employed in case of the defaulters are slightly lower compared to those of other applicants. So to summarize, a proper analysis in all of these three factors is to be taken into consideration, and they could help us to identify the weak pressure points that could help bank come up with better loan disbursement decisions. Now, Shivam will speak about our analysis on the risk undertaken and the opportunities we have missed in this field. Over to you, Shivam.
Yeah, thank you, Ayush. Yeah, next slide, please. Yeah, so in this slide, we are trying to analyze our past decisions by benchmarking on current default status of the applicant, basically to highlight and understand the missed opportunities or risks that we have undertaken. So basically, the underlying assumption was if the current loan status of the applicant is not default and we have previously declined their application, then that's clearly a case of missed opportunity where we could have made some extra bucks and methodology needs to be revisited. Similarly, if the past loans were approved and the present status is default, this shows a risky lending case from bank side. Okay, so the first point, this gives some overview of the lending habit where around 62% of the loan applications are accepted. Here we are interested in cases where accepted loans are risky or rejected loans are non-risky. Okay, so next point, this shows the impact of intent of loan that is taken for repair purposes are more prone to default, whereas the loan taken for business activities or real estates are less risky. Yeah. So next point talks about the missed opportunities in terms of revenue and prospective clients. It can be seen that the individuals whose cash loans were cancelled before tend to default less. That was coming to be around 9% when at present. When we compare it to the overall benchmark default, which we have calculated, that was around 10%. So yeah, this is one of the case of missed opportunity. Next point is very interesting. It shows the applicant with academic degree who got the loan cancelled in the past have zero default rate. Okay, so we can say that maybe the data was like this, but yeah, this is what we have got for this particular case. This is a major opportunity miss that we can see. After this, the applicant with widow family status having their loan cancelled have very low default rate in the present. Therefore, they are again a case of missed opportunity. Okay, so present default rate for approved applications of the office appliances category, that is like greater than 9%, is higher than the overall default rate of the approved applications. This is an unwanted risk and it should be minimized. So in summary, risk is either in the form of direct loss or opportunity cost, basically what we could have given, but we have chosen not to give. So to minimize the risk of losing a top line, banks should be aware and more strict by approving these kinds of category loans. The effective interest rate that we charge should also take account of the risk that bank is undertaking. Yeah, next slide, please. Okay, so this is the final slide where we would like to address some business or tech-related solutions that are currently present in the market. Starting with tech stack, we believe that data integrity is a very important issue. If your no model will work well if you don't have a very good data, and good data means also not only the amount but also the quality. Basically everything should be verified and checked. So yeah, there are certain frameworks that work around that. Other than that, data integrity, we would like to talk about the modeling and basically the fraud detection frameworks that are present that can help you identify if there is a fraudulent activity in very less time. In terms of business solution, our recommendations includes, but is not limited to, the integration of automation with the ML techniques that can help to minimize the human error and reduce the TAT. And ultimately, we have to reduce risk. So yeah, that's all from our side. Thank you.
Okay,
Thank you,
great.
Yeah.
Yeah, so I wanted to ask you a few questions. First of all, how did you come up with the three key factors? This ability to pay and willing, whatever, the first slide, right?
Yes, yes,
So
ma'am.
did you decide them on your own, or was it based on data?
No, no,
Willingness
ma'am.
to pay, ability to pay. Yeah.
Yes, sir. So, ma'am, we did some research, third-party research, and we saw that these are the broad categories. Basically, this is more of a domain level information.
Okay, and I'm not able to understand your categorization. I need some help there. So in willingness to pay, you have mentioned employment type and gender. So I'm not sure how it is like correct, because gender will not come in willingness to pay. It should be like a demographic variable, or person related variable. It's not a proper categorization according to me. Maybe in willingness to pay, you could have mentioned income. That would have made far more sense.
Yes, ma'am. What we thought is income basically defines if we are able to pay or not. That is, so we kept this into the ability to pay. For willingness to pay, we considered this male or female, the gender category, because we did not find any other explanation for this gender biasness. That is female, that is male defaulting at a higher rate compared to females. So this we include, so we include this because we consider it in this way, that female are more diligent, they are and hence they are more towards fulfilling the liabilities that they have. And on the other side, male have this is
No,
something
it's not about male female. Okay, it's about your categorization itself. So I don't think it should come in willingness to pay. It has no relation at all. So gender doesn't have any relation with whether you are willing to pay or not. Okay, and even your housing type for that matter. And it is written employment type on top. It's written housing type in the graph. So I'm not sure what this graph is exactly telling. So the categorization itself, right? I have a problem with that. Then you have mentioned that the mean age in some others. Can you please go next? Let me tell you which slide. Yeah, the next slide. Yeah, this one. So you have mentioned that the mean age of defaulters is slightly lower, right, compared to the other applicants. So how significant is it for a population? How do you know it is significant? Because if one age is 28, other is 29, it doesn't necessarily mean, you cannot take on, let's say you cannot make an assumption about the population based on a difference in the sample data. You understand what I mean?
Yes,
So
ma'am.
is
Yeah.
it significant enough, or is it not? It could just be it would just be by chance. Okay, so if it's just a 1 or 2 year gap, it doesn't really mean anything, to be honest. So how are you coming to that conclusion?
yes, ma'am.
Yeah, ma'am. Yeah, Ayush, yeah, continue.
Yeah, so it's not just the median that was lower for the list for the defaulters. Also, the various quartiles, the age for the various quartiles, that is also very low for the defaulters. Also, the data, that sample that we have was large enough to make this hypothesis that we have made. And for your previous question, we have included what we thought is that the willingness to pay includes the intent. What is our intent, that if we are willing to pay the loans or not? When we have a larger thing at stake, maybe a house at stake as a guarantee, then we are more willing to save for those payments in compared to when we have nothing at stake. So that was our thought when we include those factors in willingness. And over here,
I think that categories you will have to relook at it, because it's anyways very similar to ability to pay.
Yes,
It doesn't mean anything. Okay, so ability to pay is good. Maybe you could have had demographic like gender, income, whatever in that. Okay, and I don't know what was the third variable. Let me see. The third one was verification factors. So how will you even measure that in your model? You can't, right? You cannot use ID in any model. What will you even do with that?
No,
I'm
we
not
have
able
a
to
column which
understand.
was the days of IDs, the days, the recently published ID, the days until which the ID was published.
So that could also come in the demographic variables, and then probably you should have had another broad category, which is past history or something. So I'm not satisfied with the initial slide itself. Okay, the structure itself, let's say. The other things are good. Visualization was good. Recommendation is also good. But yeah, you could have worked probably on the structuring of it. So that is my feedback. Ashwin, you can just take up.
Hey, yeah. Can you move to the next slide where you had the income? Sorry, I think then it would be the yeah, before this. Yeah, so over here, right? Again, a feedback to you that the heading and what is there below is not making sense. Housing type and credit range default is not what you have mentioned in the slide below. So some more focus on building the slide right headings. So on the credit range, right? You mentioned that 3 to 6 lakh is what we should focus on, right? I'm just trying to understand that the greater than 9 lakh risk seems to be the same as less than 1 lakh. How do you think this is happening?
So we think that the reason for the defaults are very different in these two cases. For greater than 9 lakh, the reason for default could be maybe cutting down the source of income for the individuals or other factors. But for 1 lakh, for less than 1 lakh, yeah, just a minute.
Adding to this whatever higher income has a less default rate. Here we have a support in this particular slide. That 1 second. In employment, like we are seeing that businessmen and commercial like businessmen and state servants have a comparatively lesser default rate. So maybe they are earning more and they have a less default rate. So these two are complementing each other. So this was the reason what we have thought.
Okay, I'll ask you the question this way. Which employment types do you think make sense to apply for greater than 9 lakh loan?
Maybe businessman
Businessman,
or yeah,
and probably students, it depends.
But it's mostly businessman, yeah.
Students, businessmen or students?
Businessman and working, I guess. For students to have a greater than 9 lakh, maybe student also for students loan, but mostly businessman.
Okay, but those who would have higher income would be the one applying for higher credit range as well, right?
Yes.
Yeah. I'm just trying to understand, like if you see on the income range also, right? Like, don't you think the income range and the credit range are not matching to each other? Like,
The credit range for those who are applying for greater than 9 lakhs may not necessarily have a salary higher than 5 lakhs. For example, though there are very few cases, but there are cases of students applying for loans, which are also of larger amount. Then there are other individuals who have guarantee to back up those loans, but not proper income. They are also applying for these loans. So the loans greater than 9 lakhs is greater than for income range, which is greater than 5 lakh. I would say the income range is a subset of credit range. Those who have a given income would always ask for a loan greater than their income. But vice versa may not be true.
Sorry to interrupt. The time is up. Thank you, team Outliers.
Thank you.
Thank you.
Ma'am, and sir, let us know when you are done.
Yeah, you can. I mean, I'm done.
Ashwin?
Yes, I'm done now.
Okay. The next team is the Incredibles. Please raise your hands and share your screen. All the best.
Yeah. Good evening, everyone. We are the Incredibles from IIM Calcutta, studying postgraduate diploma in business analytics. So I am Kiran, and I will start off by explaining the problem. We were asked to minimize the risk of losing money and opportunity while while lending loan to the customers. And this can be done by employing a classification model based on the various factors present in the application data and the history of the applicant. So initially, Nitish, can you change the slide? It's stuck there. Yeah. So initially, we have taken the application data and we have done a left outer join with the history data. Here, the application data is on the left side. Then we have checked the number of none values in each of the columns, and if that number is greater than 20% of the number of rows in total, then that particular column is removed. After that, we have filled the missing values in the numerical data using interpolation, and we have filled the missing values in the categorical data with the string NA. Then for categorical variables, we have done chi-square test to find the significant variables. That means here we're checking whether that particular categorical variable has any impact on the target or not. Then for numerical data, initially we have done correlation, and from the correlation matrix, we have removed the spurious variables. That means the variables which are linearly dependent on each other. Then on the remaining numerical data, we have done logistic regression on each variable and the target to see if one particular variable impacts the target or not. So after doing that, we have encoded the categorical variables using label encoding, and we have split the data into 70:30 ratio. And since the encoded categorical variables were nominal in nature, we have used a decision tree classifier. So as you can see, these are the final 72 variables, and the accuracy of the model is 98.17, which is pretty high for a classification model. So we can confidently say that we can use this model to predict whether a person will have difficulty in paying or not. But these 72 factors can also be filtered out into 20. Next slide, please. Yeah. So what we've done is, after calculating the initial accuracy of 98.17, out of the 72 factors, we removed each one of them and we check the accuracy again. So what we are basically checking is, after removing any particular variable, what's the percentage of dip in the accuracy? So the most important variables are the ones which have the most dip when they are removed. So after doing that, we got 20 variables, and we have split them into client and loan factors. And when we train only with those 20 variables, the accuracy improved to 98.8. So now my friend Nitish will continue and give insights about these factors.
Yeah, good afternoon, ma'am. So basically, we got 20 factors out of 72. And among those 20 factors, we have categorized them into client factors and loan factors based on our understanding about the data. So basically, client factors will be having all the personal details regarding to client, and the loan factors regarding ratings and credit inquiries and all. So I will be discussing the client factor insights. Yeah. Basically, we have two factors here: occupational type and average amount of income as a two variables among the client factors. So these are the top 9 occupational types with average income above 2 lakhs. So since these two are our important factors while considering the decision tree, we can prioritize these clients from these occupational types as a for approving the loans to minimize our risk of fraud. And on the right, you can see the a pie chart for income source versus own houses. Like people with income sources from working, commercial associates, pensioners, and state servants are having own houses, whereas the remaining people are staying in a rented apartments or government apartments like that. So people with own houses will be having a collateral or a liquidity, which in case will be low risk for us while granting loans. So we can prioritize the people from these income sources while approving the loans. So for the remaining client factors, we have generated the correlation coefficient using the target variable. Here, target 0 implies that the client has no payment difficulties or late payments during previous history.
whereas target variable 1 implies that he has payment difficulties in the history. So for here you can clearly see there are two, like positive correlation coefficient and a negative correlation coefficient. Here the positive correlation coefficient implies that here, for example, in days birth, the more the number of days birth while during the time of application, more likely is the applicant to be fraud. But in our data, our most of the data is comprised of people of age group around 35 to 42. So here it might be partially biased while concluding this point. So similarly, in the negative correlation coefficient, we can say days employed. For example, if the number of days a particular client has been employed before like applying a loan is more, he is less likely to be a bad client. So here positive correlation coefficient implies that he has a positive linear relationship with the target variable, wherein negative correlation coefficient implies that he has a negative linear relationship with the target variable. Similarly, we have done this for all the other variables also. And my friend Manoj will be presenting the remaining.
Yeah, thank you, Nitish. Good afternoon, everyone. Now I would like to take you through the insights which we have drawn based on the loan factors. Based on one of the loan factors, which is external score from the credit bureau, some external source, we can see there is a relation between the educational qualification and the average score of the external source. As we can see in this bar diagram, the higher the educational qualification, the higher is the external source score. Similar is the case with similar is the relation between the educational qualification and the client's annual income. The higher the educational qualification, the higher is the annual income. In this table, similar to the client factors, we have mentioned the correlation between the target variable and the various loan factors. For example, in the first row, we can see there is a negative correlation. There is a slight negative correlation with the loan factor, which is external source, which indicates that the higher the external source score, the less likely the client is going to have any difficulties in the repayment of the loan. Similar is the case with the external source 3 score. The third row, which essentially is the total number of inquiries, the total number of inquiries to credit bureau. It is slightly positively correlated with the target variable, which says that the more the number of inquiries yearly, the higher is the risk. The higher the customer is prone to face any difficulties in the future. Similarly, we have listed how the different loan factors is affecting the target variable in the slide. This is it from our side. Thank you for giving us this wonderful opportunity. Thank you.
So I would like to say, first of all, thanks a lot. Good effort at the technical model. So one thing I wanted to ask you, you are saying that the accuracy is 98%. What do you think of overfitting in this model?
Actually, yeah, it may have been possible, but we were splitting the data in 70:30 ratio. I hope that will overcome it slightly.
Okay, I don't think this much of accuracy is possible because it's too much actually. So this model will not work on any fresh data because it's very overfitted. So I mean, that is something that you might have to look at. Also, slide 6. Can you go to slide 6, please? Loan factor. Yeah, this one. I think I'm not sure it's so. Days ID publish, right? I'm not sure if it's. Let me tell you. Wait. So it is this client factors slide. Yeah. So days ID. No. This one, correct. Just stay here, please. So the third bullet, right? Days ID publish should be as less as possible for the client to be good. Do you mean his ID should be freshly published for him to be good? What do you mean by this statement?
Here, according to the correlation coefficient, it says that more the days after the days ID published, it will be more possible that the client to be fraud.
Yeah, so basically you mean if somebody's ID is published
Yeah,
today,
it should be freshly sub. Yeah,
yeah. So I don't know. One team, I don't know which team came before you. So they said the exact opposite. That if somebody is changing his or her ID many times, or just recently changed, then it's bad. Are you very sure of this point? Leave alone from the data perspective, even otherwise. If you're telling this to business, that if somebody has just newly joined a company, then he is likely to be a better person to loan out to. Does it make any sense? It's not just about data. It's also about the business implications to it. And if we are making such a statement, then we should probably make it more nuanced, as in how many such people are there in this data set. What is the average loan that you have given? What's the average default been? So I would like more details on such type of statements, which are not so intuitive. Hello?
Yes, ma'am. We have to learn, yeah, as you said, the data itself may be overfitting and all. We can do data, we can clean the data perhaps before proceeding and giving the statements like this. But as you've said, if we do this, maybe we should say, we have to tell this particular scenario only from this person, from this amount of loan to this amount of loan only, this is valid or something like that. We must do something like that.
Yeah. So I think your technical analysis was excellent. I really liked it. What I would wanted to have right, more business, more, let's say, recommendations. So this is more of an interpretation of your technical analysis, that this variable is positively related, this variable is negatively related. That is good. I'm not saying it's wrong, but to a business stakeholder, right? I need something in maybe one slide. What should I do as a business leader? Which type of people should I give loan to? What are the different type of people I have to loan? What is the loan amount I need to give? So I'm not able to see that in this presentation. Do you have any answers for that?
Actually, we have totally built this presentation based on the technical model itself, based on the decision tree. So that's how we made this.
Team, that's all right. But if you had to recommend, let's say that, I am asking you that, I want to sort of, be aggressive on the way I give out loans, right? And I want to give out loans to, let's say, blue collared workers. What are the top 4 things that I should be, you would be recommending to me, based because of the fact that, you've done so much analysis? Tell me the top 4 things that I should be looking at while making this decision.
So firstly, we can say that external source, whatever the score that we got from the bureau or something, and days employed can be one of the factors. Which can you go to the previous Nitish? Yeah, this one. So from this, we can choose the top 4, the days birth or days employed, and the external factors, because these are the ones which impact the most the accuracy. So again, we are going from technical aspect only, but even intuitive also, I think this must be valid, right? Because if the score is, the external score is high, the CIBIL score or something, then we can say that we can proceed and give the loan.
That's correct. But then you have the ability as a bank to collect so much more nuanced data, right? Your first factor, if it is external factor, if you see what other teams have also highlighted, is a more of a good to have or a nice to have in case of some percentage of applicants which you are not sure of based on the data you've collected, right? You seem to be saying that that's the main thing that we should focus on. And given the fact that one of the factors you're mentioning is days employed, which according to me is a bit of a question mark, because anyone who has recently changed a job would not really have high days employed, right? And in general, your model seems to be indicating that change is bad. Would you want to rethink on the recommendations that you would want to make for the top 4?
Yes, sir, definitely. What we could have done is we could use some, as some other team has also done, we could have done some research based on the domain knowledge. We could have made some extra feature engineering, and that modeling we could have done. So domain knowledge we could have employed more.
Got it. That's it from my side. Sure.
Thank you, sir.
Any more
Thank you, ma'am.
questions?
No.
Thank you, ma'am, for
Guys,
the
you can
feedback, and
stop
thank you, sir.
sharing. Do let us know once you are ready for the next presentation. The next team would be Team Trident.
So I am done with mine scoring.
I'm done as well.
Okay. Team Trident, please share your screen. And we would be requesting all the participants to be on video if possible. You may start now.
Good afternoon, everyone. We are Team Trident. We comprise of Pankaj, Parth, that is myself, and Shobit. And we are here to present our solution on the given problem statement, which is to provide the client factors and loan factors to disburse the loans for OJAS bank, and also to provide a comprehensive framework for taking the lending decisions. So the approach overview that we have taken is that firstly, we have gone through the initial information available along with the feature engineering. Then we moved on to the WOE and information value calculations in order to identify the important feature dimensions. And then we applied that to a particular model that is a logistic regression. We'll be talking about it in the subsequent slides. And from that, we made a lending decision framework and further moved on to the business strategy and the future avenues. So let's get started with the information available and feature engineering part of it. So we were given two data sets, that is the application data and the history data. So as we can see from the history data, the number of data points was too high than the application data. And it was not also unique on the ID variable that was there. So what we did was we took the data set and segregated it based on the name contract status, which is the past type of loans that the customer had taken, like the cash loans, consumer loans, revolving loans, and XNA type loans. And then we performed aggregations like sum, min, max, and mean, also segregating like based on the name contract status. So using this particular approach, we came up with, we merged the data with the original application data, given that the IDs had been unique now, and we came up with the number of features as 1169, which is way high, and we wanted some mechanism to reduce the number of features and highlight only the important ones. So in order to do that, what we did was we split the data into 70 and 30% ratio using simple random sampling, and we ensured that the event rate, that is the percentage of defaults in both the data sets, that is training and validation, remained the same. That is about 8%, which is also highlighted in the table. Now, further, in order to identify the important features, what we have done is the information value calculation. So for every variable, we have divided it into 10 deciles. And for each decile, we calculated the information value based on the given formula. And summed it up across all the deciles so as to get a particular indicator for the power of differentiation in the variable. So how much power does the variable have to in order to identify the target variable. So the maximum IV that we saw was the external score 3, followed by the external score 2 and 1. And along with that, we had days employed. So we came up with a cutoff of 0.05 in the IV, and we ended up with 26 variables for the model development. Further, what we did what we did was we reduced the features based on the pairwise correlation. We looked at the pairwise correlation and reduced the features to 16, and which is the number on which we build the logistic regression model. So if you see on the left hand side, we have highlighted the top IV variables that we could find from the data. And further, these variables were transformed using the WOE transformation and fed into the logistic regression model, which we'll be talking about in the subsequent slides. Next slide, please. Yeah, so using the information value, we came up with the important feature dimensions which are highlighted over here, like the employment tenure, the age of client, the days since first drawing, or the application amount, and so on. So over here, we have highlighted a few features that we could see a clear trend on based on the deciling that we have done for the variable. For instance, if you see the day's birth versus the bad rate. So as the bin number increases, we see a clear trend, a monotonic trend with the increasing bad rate. So over here, the 9th bin represents the population that is of the lowest age bin because the variable was negative in the data set. So that's how we have come up with the trend, and it was pretty intuitive to us. So we went ahead with these variables and built the model, and the model results will be discussed by Shobhit. Over to you.
Thanks, Parth. Hi, jury. I will be discussing the lending decision framework and the modeling techniques. So this slide will be majorly a technical slide. So the modeling techniques that we used was logistic regression, and the logistic regression model was built on the 16 features that the Parth discussed in the last slide. Now, based on the logistic regression model, we used KS statistics, that is Kolmogorov-Smirnov statistics. It's a non-parametric test. KS statistics gives us the 36.3% gap between the percentage of bads and percentage of goods. Basically, KS statistics give the maximum possible gap between the bads percentage and the good percentage. As available from the trained dataset graph, you could see that the KS statistic is maximum for the bin number 3. Hence, we have taken KS statistics 36.3 for the bin number 3. And we could also see that the the distribution of the data set in the train and validation is similar. Hence, we could say that our model is robust and would perform evenly in the unseen data set. Now, the model output score in the range of 0 to 1. Higher score indicate more risk as we move across. Now, we would look upon the tables that we created based on a model predictions. Now, we have created 2 models here based on the cutoff score. Now, the first model of cutoff score of 0.091 indicates a more conservative approach in which we decline 30% of the population to avail the loan. Now, based on this set, our recall would be high, but our precision will take a hit. Now, if a bank want to take a more aggressive approach, then we could employ a cutoff score of 0.12, in which we would decline just 20% of the population to avail the loan. Here, our recall would drop down, but our precision will take a boost of 0.2. Next slide. Now, based on the business risk appetite, bank could employ either of the model with different cutoff scores to take the decision of deploying the loans. Bank could also take, as I said, take a cutoff score of 0.112 to approve loan for high-risk customers. And also we could convert the model score to a credit score by multiplying by suitable factors. Such suitable factors should be selected such that we preserve the rank order of the customers and also avoid score clumping. Like currently a model score is between some decimals, we would deploy a constant score of 10,000 to give out a credit score. Now I will discuss the business strategy that we like to consult our bank. Bank need to leverage some of the parameters and based on a model output, and also could be a domain-based parameters. And like for example, here we have divided our customers into 3 sets, like risky customer, moderate, and safe. Now, our parameters that we have taken are as follows: like average age, like in the first group, average age is around 35. In second is average is around 45, and now the last is average age is 49. As also evident from the age of the customers versus debt loan, as discussed by Parth. Other factors that we've taken in account are tenure, that is employment status, employment length, amount that they are seeking through loans, and also the credit score. Now, based on these factors, the population distribution in these data sets through our model output are 35%, 10% in moderate, and 50% in safe category. Next slide, please. Now, some of the future avenues that we like to discuss based on model findings and also on domain knowledge are as follows. Based on the profiling created, bank could be involved in community marking. Banks see an influx of customers with a particular need. For example, rural area banks see a particular set of customers with agriculture background. Then bank could launch policies that cater to those particular requirements if they are deemed to be safe. Also, teller referrals. Bank could also leverage the expertise and the experience of tellers. They could be trained to look out for opportunities such as referring customer to a specialized loan products. Also, the new technology deployment. Banks should also adopt digitization at all possible touchpoints, promote customers to have digital signatures and leave data impression to avoid fraud and smoothen out the bank process. Also, they take advantage of automation. A lot of banks nowadays creating in-house or hiring third-party company which offers customized AI advanced customer service to provide to ensure smooth user experience. Also, to clear complaints, banks should incorporate that. Also, product bundling. Based on the user profile, bank could bundle their multiple products into a single offering and sell it to a customer. For example, offering a small loan with a fixed deposit account opening to those customers would have low deposit amount and have safe credit score in the past. Also, pre-approved product, bank could review their existing customers and look out their trends. If they're positive, then could offer pre-approved loans or credit cards. Also, another advice to offer premium services to a small niche customers, bank would sign private set of bankers to personally handle all the transaction of such high-end spending customers. So that's the end of the slide. We would like to thank you and are ready to take up any question and suggestions.
First of all, great job at the technical model and overall everything actually. The only thing I want to ask you, right, the business recommendation, how first of this future avenues, I'm not able to tie it to your analysis. How is, because this is not, let's say, just a generic recommendation. It should ideally be, based on data that you have. So how are you tying that?
Right. So like we have identified 3 customer segments based on the data that we were given. So in order to target such customers like the second and the third category, the moderate and the safe category, we came up with these ideas that the bank could incorporate within its reach. Right. So
no, but how are you tying up use of automation? Yeah. How do you know that is a problem? And that is why we are having more defaults. So it's not really relevant to, the question at hand.
Actually, we have taken also the use of the domain knowledge in the banking industry. We just don't want to rely on the modeling aspect and then give recommendation, but also add the domain expertise here.
Okay, so add some recommendations from only the data. What are the other recommendations based on the analysis so far?
First one was, as we discussed, we could deploy different models to take to judge the risk appetite of the bank and then deploy models. Deploy loans to those customers which are slightly risk or prefer low risk appetite and offer customers loans to only those set of customers which have high credit score or high model output score.
Right. We could place in some non-negotiable policy criteria for the customers that come in, like a hard cut for the age or a hard cut for the external score, let's say, because those were the important parameters that came in. Also, if a customer is newly employed, then we could keep a hard cut, like let's say 6 months or 1 year at minimum. They need to be employed for that particular amount of time.
Okay, please go back to slide number 5 once. Where you have drawn some bins for date of birth, I think date, days, age, something. Yeah, this one. What is the 0? Is it the number of days? What is that? 0, 1, 2,
that
3,
is the
bin
x-axis. That is the bin number.
What is each bin?
Each bin is okay. The bins have been defined based on the variable, that is the day's birth, let's say, the variable at hand. So we have divided the data into 10 equal bins based on the date birth.
No, what is that? What does the 0 x-axis mean? What is the age
Okay, so over
Upper
here
limit, lower limit.
Yeah, over here we could not showcase that bins, but they are like monotonic bins, from 0 to some value. Then okay.
You mean 0 years of age to 1
Not
year of
zero.
age?
The
Then,
minimum to the maximum going in that particular order.
so
Given
what
that,
is that minimum and what is that maximum for, let's say, the first bin?
sure, just a minute. The minimum is minus 22,181. This is the number of days, and the maximum is, I guess, minus 7489. Yeah.
There's a problem with your data. How can it be negative? Days of birth.
So the data that was given was such that they had subtracted from the from today. They subtracted the day of the birth date of the customer. So you would get negative in that case.
This in year terms, what does it mean? It's not about the data. I mean, if let's say I'm a business person, how do you explain what is the range of that age? I don't want 22,000 years. I want in years. It's 32 years, 22 years. What is it?
It ranges from 60 years to 20 years.
60 years to 20 years is the first bin.
No, the total.
What is your first bin?
The first bin, okay. The first bin ranges from from 56 years to 60 years. The first bin.
And what is the second bin? And how why is it not let's say in any order?
So it's in an order. It's in an order. Like given the data was negative, the bins are reversely ordered. That's the whole point. So the first bin is from 56 to 60 to 56. Then it goes from 56 to 51. Then it goes from 51 to 47 and so on till 20.
Okay.
Yeah.
So you are saying, okay, the youngest people are most likely to not default.
Most risky. Yes.
Least risky. Okay. And does this also take into account the number of borrowers? Because I don't think so, right? It's just the age. But it's possible that people in 20s are very less and probably
the population percent is same across bins. If you see the orange line, that gives the population percentage for the sample. So it's constant 10% for every bin. The bins are designed such that the population percent is same across the bins.
Okay.
Yeah.
Fine. So yeah, I think I'm done.
Yeah, general again, I would say the structure of the presentation is good, but I would say there is a lot of, cognitive load for me to understand and interpret your graph. I think if that could have been, lower, it would have been easier and so much explanation may not be required. Finally, on the recommendations, right, I felt they are very generic and they are maybe generic for any, for example, some neobank to go and launch itself. I'm not, other than the fraud part, I could not see anything that ties back to the analysis that is done. Seemed very generic. Having said that, let's assume that, I am risky Rishabh. What is it that I would have to improve to get a loan from OJAS banking and financial services?
Okay, so the customer would have to build the credit profile. That's the primary criteria that we would say based on the analysis that we have done so far. So they need to build their credit score and have some more tenure that would give a bank a sense of stability for the customer, and then they could approach the bank for the loan. Then they might be approved.
Okay. Cool, I'm done.
Yeah, I'm also done with the scoring.
Okay. Thank you.
Thank you.
Thank you, team. The next team up is Team Zephyr. Zephyr, can you please raise your hands and share your screen?
Okay, am I audible?
Yeah.
Okay, I'll be sharing my screen.
Just raise your hand, Hitesh.
Actually, wait. Is my screen visible?
Yeah, it's visible.
Okay.
If you could just go full screen.
Wait. Yeah, you can start. Finished?
Okay. So good evening. Hide everything. I mean, there are some obstructions on the screen.
Where I don't know how to do it. You can start, by the way.
I hope it will be okay. So good evening, everyone. We are from Team Zephyr, representing PGDBA batch of IIM Calcutta. So we are here to conduct a risk analytics case study for OJAS banking and services as a part of Techtonic shift. So over to the first slide. Hidesh, please go into the first slide, please.
I'm on first slide.
So the problem statement. So the given problem statement was like, OJAS Banking and Services is one of the leading credit provider, and recently it has noticed loss of money due to difficulties in payment for some of the customers. So we are required to minimize the risk of losing such money without compromising the opportunity. So from the given data sets, we are required to gain some business insights and build a model which could be used by OJAS Banking and Services so as to reduce their losses. So this will be the part followed by us. We have come up with the data preparation DDA, and we have built a model, and we have basically built an application scorecard, and we'll discuss the feasibility of the application scorecard in the final slide, discussing the financial benefit. So quickly over to the next slide, please. So this was a dashboard analysis for the top continuous features in the defaulters category. So as you can see, the graphs speaks for themselves. So still I'll explain. For example, about 15% of the people defaulting population are from the category like they are taking credit amount worth 1 lakh to 3 lakh. And when you see the debt income ratio, it's about 0.08 to 0.14. And the most interesting factor is the employment, and people who are employed for less than 4 years are defaulting the most. And the external source too. On all these 6 features, these are most important features in our final model building. So, and the external source too shows the difference between the non-defaulters and defaulters. And when the range is 0.05, the defaulters and all the defaulters above 0.5 approximately are not defaulting. So going on to the next slide, going on to the next graph, which shows the percentage of defaulters versus the age. So here also we cannot clearly conclude something from along these graphs. So we need to actually splice the data again. So next slide, please. Next, it shows the categorical features for the defaulters. We can see occupation type, income type, education, gender, count of family members. All these will give you an idea on where the income defaulting populations are coming from. Like the percentage of defaulters are about 20% in the case of unlisted or laborers or sales staff categories. And those people who are working type, income type has more than 60% defaulting percentage. So, but still something is missing here. So we cannot actually conclude something based only on these graphs because the data set is a lot tricky. So what we have done is we need to measure actually the credit worthiness of each individual. So for that, we have built an application scorecard, which will be discussed in the coming slides. So moving on to the next slide regarding the data preparation and modeling, it will be taken by Hidesh. So over to you, Hidesh.
Yes, sure. So the first stage of modeling part was the data preparation. So we split the data into 80 to 20 ratio. So 80% was used in training that model and 20% was used for testing it. Since this was a case of highly imbalanced classes, 91.9% of the time people were not defaulting, and only 8% of the time they were unable to back the loan or had the difficulties in paying back. So next thing was feature selection. We calculated correlation graph. We dropped some features based on correlation. So those features which were correlated to each other, we dropped one of them and we kept the other. Next slide. What happens in credit risk modeling is most of the time we'll be calculating weight of evidence. What the weight of evidence suggests is the predictive power of that feature. And mostly it is used in logistic regression models. We have implemented weight of evidence, we calculated it, and with information value. So information value or the p-value is used in feature selection. So if p-value comes out to be less than 0.2, it is not useful for prediction. And if it is 0.3 to 0.5, it will be a good predictive power. It will have good predictive power. For the modeling part, we implemented logistic regression, and based on that, we came up with the final results. So this was the model performance that we implemented. So in order to evaluate our model, we used area under the curve of ROC, which came out to be 74%, around 74. And these were the accuracy, sensitivity, and specificity we got. Accuracy was 74%, sensitivity was 75, and specificity was 68. What it says. So if I'm saying specificity is 68%, it means 68% of the time we were able to capture those borrowers which actually defaulted in their loan. 68% of the time we were able to capture that, and sensitivity says it was 75. So those 75% of the time we were able to tell how many of the borrowers will not default, and accuracy was 74%. How did we got the means what threshold value will be used? That in order to select that, we actually did a financial analysis kind of thing, which will be on the last slide. So these values were basically selected using the financial analysis. Next slide will be explained by Wahab.
So okay, coming back to me. So this is the most important part where we build the application scorecard. So we retained all those values, all those coefficients from the logistic regression model and scaled them to 300 to 850 range, because that's a standard FICO range criteria for credit card models. And now the final scorecard for an individual, it will be just a simple matrix dot multiplication between the test set and the final score for each category. For example, on the right hand side, you can see how the scores are evaluated. The score would start with an intercept value of 585, and all those people who are pensioners will get an additional point of 22. And we had to come up with a cutoff score of 618, and all those people who are below 618 would be rejected. So over to the next slide, please. And the financial analysis, like all those people who are below 618 were rejected. So our model was able to predict around 75% of the correct rejections in our test data. So coming to the financial analysis, this is a just rough analysis, or you can say it's the worst case scenario analysis, where we have around 3,758 defaulters which were actually captured. And if they are defaulting the total amount, the whole amount, we would lose around, we are actually capturing them, so we won't lose this amount, 1869 millions. And we would lose a lot of customers, 14,000 to be exact, 14,674 customers to be exact. And the net revenue loss due to these customers, it's around 2,522 million. And the monetary benefit for the bank using our model is around minus 654. So it's minus, it's negative, but still it's practically more significant, because let me tell you how much the monetary loss would be there without the model. So without the model, it would be around 2,757 million, and monetary loss using our model accounts to be around 1,254 million. So we were able to reduce the losses by half. We were able to reduce the monetary loss around by 54.5%. So this is actually the worst case scenario in which I assumed that the interest rate was around 6% and the tenor of the loan was around 5 years. And it comes out to be fruitful. I mean, we were able to reduce the monetary loss by a great margin. So our model actually works. So that will be the final analysis part. That's all. Thank you.
Okay, thanks. So I think, yeah, technical model wise, it was decent. What I am looking for is business recommendation. What do you recommend basis your whatever you have done, right? To
So
the company.
so in the can you go on to the first two slides, please? From the first two slides itself, we can see we cannot actually interpret much from those graphs because these are just if they are shown uncorrelated with each other, we cannot say like all those people belonging to the employment category from 0 to 2 years will actually default, because there will be much larger population who won't default. So my recommendation to the company is the scorecard model itself. Use the scorecard model and reject everyone below 618. That's a cutoff score which was analyzed using the Jordan statistic.
Okay, you are saying basically basis, I think logistic regression you used, right? If I'm not wrong.
Yeah.
So whatever model you have made, if the score overall is less than 618, reject it.
Yeah.
So you are using a classification or a regression in this case?
Actually, I want to add one more thing. The cutoff score is just a threshold value, like 618. If our model says around 618, then there is a way of finally choosing. So in the earlier times, what used to happen is there was a switch position as credit analyst. What he used to do is he used to look up all the documents, then he came up with like, you will get the loan or not. It was the job of the credit analyst. So if the score is coming around the threshold value, what we can do is a credit analyst will just go through the history data of the customer. Then he might decide if he has to give the loan or not. If it is not around the cutoff value, then simply our model can predict. If it is higher than that,
Okay, fine, I get it. So are you using a classification or are you using a regression? What exactly are you doing?
We are using the logistic regression model. It's a kind of
classification, right?
Yeah,
classification, multi-class classification. So okay, so basically those 5 classes that you have listed.
That is for prediction.
Yeah, that's what I wanted to check. So and which metric are you prioritizing? Accuracy, sensitivity, or specificity, and why?
We are actually trying to get the balance out of this. So what in credit risk model we want is, we want to capture a maximum number good amount of borrowers which will actually default. Taking into consideration, we also want those customers. We also want to identify those customers which will not default as well. We have to have a good balance of these values. And we
okay, so let's say you have to choose one.
We want to capture those customers which will actually default. This will be our main priority. And based on the financial analysis we did, using these values, these output we got, that's how we choose those values, sensitivity and specificity.
I mean, I would like to add more point there. I mean, specificity actually shows how much of the default population you are able to correctly predict. So we actually want to reduce both of these, false positive and false negative. The reason why I want to reduce false negative is that is actually the profit for the company. So if that number is coming high, the profit would actually go down.
Okay, so this is good. I mean, whatever you explained is great. So only business part, I'm still not very convinced. Technical, excellent job. So you are saying that we use the model and whatever prediction we get, we just use that, right? So that is one recommendation. Do you have anything else to add, or that's all?
The problem with this data set is that it's little bit tricky. I mean, we cannot conclusively say that a person belonging to the male or female would definitely default or something like that. So that is why even if in the case of any continuous variables like salary, we have what we have done is that we classified into discrete bins. Like in this particular case, we took into 50 bins and calculated the weight of evidence for each bins, and then applied the logistic
See,
regression
if
model.
you explain this to anybody, right, to any leadership, they will not understand. So the technical part is good, okay, but everybody will not be that technical. So you are saying use our model and whatever prediction you get, use that. That is okay. I am agreeing to that. But I don't know. I mean, ideally, you should have some other recommendation also that this is the typical profile of a person who is more risky, or this is a person, I don't know, something like that. Also, if you can add.
Okay. Can we just go to the first slide, please?
Yeah,
So
I mean,
essentially, team,
because
like I also wanted to sort of give this feedback only that see, you've said that your model is banks can stop using their model and can start using model because you will qualify more customers, right?
Yeah.
That is what is your basic recommendation.
Okay.
And you said that around 75% point, and you've added shown some numbers, right? And let's say that I agree with you that there is a limitation with the data set that what are the points that you can take outside this data set if I want to be more aggressive with the amount of people I want to qualify?
Like the general conditions. Okay. Please show the next slide, please. From these graphs, we can actually conclude something like all those people belonging to the laborers, sales staffs, drivers, these people are defaulting much higher than the other people who are having luxurious jobs or more stable jobs. And if you are taking the region rating into consideration, the percentage of defaulters are high in the where the region rating is approximately 2, and the percentage of defaulters are high when their educational qualification is only secondary.
Got it. But this is within the realm of the data that is given to you, right? Since you mentioned that the data is limiting your ability to recommend, I was asking what are the things you could recommend if this data was not a boundary for you? What are the external sources or what other sources of data you could use to give better recommendations?
Other sources, I couldn't clearly get that.
Okay, so for instance, one of the teams mentioned social media profiling of customers, right? So some more examples, like what is it, what kind of behavior? So inherently, see, what the bank needs is, if I give $100 to this user, will this user give it back to me or not, right? So for underwriting risk, what is that demographic, or what is that sort of slice of data that need to look at to qualify my customers better?
In that case, we can consider the age category. So all those people who are having age above 30%, age above 30, are showing less chances of defaulting. So we can actually capture those people who are aged above 30 and are falling in the good job, good occupation type criteria. I mean, who are falling in the bins in occupation type criteria, like the most important one are the IT staff and HR staff. So if you are doing a social media type analysis, you could target those people.
All right, got it.
Do we have any more questions?
No, I am done with my scoring also. Nothing.
Okay. So
Team, you may please stop sharing and put down your hands.
wow, those were some incredible presentations. I'm sure our judges will have a difficult time picking out a winner amongst such impactful solutions. I would now request the judges to proceed to the breakout room to choose the winner of the Techtonic Shift 2022 competition.
So it's just one person or one team, or how many? Like, do we have 1, 2, 3? How is it?
Ma'am, top 2.
Top 2. Okay, got it.
Katisha, you may join the judges in the breakout room. Yeah, so guys, all of you present here, hope you had a great time. Meanwhile, I would like to tell you that Team OJAS has been working relentlessly to come with various interactive events with enriching experience. I would request you all to please log in to D2C portal and vote for OJAS 14 if you guys felt the experience was good for you. I'd request the logistic team to kindly share the link for voting on Zoom chat. Please do vote. It would be really helpful for us. Thank you.
Shreya, the judges are ready with their results. So should we call them to the main room?
Yeah, we may.
Okay. I request everyone to switch on their cameras.
So, hi everyone. Pratyusha, you want to go first?
No, nothing as such, ma'am. Please, either of you can declare the results.
Okay, so I mean, we just decided one team I will say and one team Ashwin will say. So you actually unanimously decided on Mahalanobis disciples, the team from ISI. So I mean, really excellent business recommendations, excellent storytelling, and even excellent, let's say, the laying out of what we should do. So congratulations, team. Great job. And Ashwin, you can declare the runners up.
Yeah, the runners up for this event is Team Data for Dinner. They scored really high on both our scorecards for tools and the kind of techniques that they've used for analysis, as well as business recommendations and the way the questions were answered. So yeah, congrats, Team Data for Dinner.
So that's all.
Thank you, ma'am.
I'd like to congratulate all of the winners. We observed first-hand experience this year at Techtonic Shift. We observed great skills and unique ideas that our participants have. I wish you all kudos for your efforts. I want to remind each and every national finalist that we at SPJMR live by two words, courage and heart. The implications of these words lie deep within each of us, and I ask that you all appreciate this adventure that you have embarked on. It was our pleasure to offer you with a venue to demonstrate your abilities. I wish you the best of luck on what I'm sure will be an amazing adventure ahead. I'd like all the winners and runner-ups to stay back. Thank you and have a wonderful day ahead.
Thank you. Bye-bye.
Bye-bye.
Ma'am and sir, you please stay back.
Okay.
Yeah, we are staying back.
You did not mention us, I think.
Oh, sorry. We'll now be taking pictures with the finalists and the judges. I mean, the winners and the judges, one by one. Logi team.
Just take it back.
And if you have taken the pic with both the winners.
Yes, the pictures have been taken.
Okay, thank you. Judges, we would request you to join the breakout rooms briefly for a discussion. Thank you so much for coming.
Thank you so much.
We have everyone here. No? Okay, we don't have all the members from the team. Guys, the logistics team will be sharing link with you all to fill your details so that your prize money could be transferred to you. Please do fill that before leaving and give me a heads up so that I can ensure it's done. And congratulations once again.
Thank you. It was a great
Thank you.
contribution.